First off, thank you very much for inviting me and the funding to come in person. I was my first in person. It's nice to meet new people and see some friendly faces and things. So I was aware part of the brief for this was that the seminar series had a lot of HPC talks, and would I come and talk about web applications to HPC people? So that's the big context. So I'm not going to show you any code. This is going to be very high level, what we do at Newcastle when it comes to web applications, how we approach different types of challenges, the pros and cons of different approaches. And then at the end, my pet peeve with the RSE community is that no one cares about user experience when they're designing interfaces. So there's a section at the end about some very basic rules of thumb that all of you can take away that will help you do design in a general sense. So a little about me. I'm head of research software engineering at Newcastle. I've had that role since I invented the role about 6 years ago. I was one of those early cohort folks, people like Paul Richmond, who effectively invented their own jobs and then applied or moved into them. I was a founding trustee of the RSE Society, so I was a member of its association when all the funds were held by Southampton. I went to the first RSE conference and threw my hat in the ring for election and was elected, and our first job was make charitable society. So my sort of background in the RSE community runs quite as long as anyone's really in it. It's not that old of a thing, but I've been around a while. Some of you may know me from when I was program chair for the RSE conference in Newcastle in 2022, and hope to see you there again this year when it returns. The RSE team at Newcastle is currently 25 people. We've grown that. When I started it and got permission to start the team, I was told you can hire one person. 6 months later, we had 9, and we've been growing ever since doing that. Another selfish part of my reason to come in person was that we've just been told that Newcastle is renewing its HPC machine. And the last time it did this 5 years ago, it spent all of the money on equipment and no staff, which is obviously a huge mistake. They realized this. The correction for the mistake is throw RSEs at that problem. And I'm now left in the unenviable position of being a web developer who suddenly needs to, run a team that manages and maintains the HPC machine. So we'll be growing again this year and adding that sort of service to our book. But surprisingly and slightly unique in the country, I suppose, is that almost all of our work, 80–90% of it, is web-based. And perhaps that reflects the person who made the team. But a lot of other groups in the country have sprung up around HPC facilities, or at least other equipment and that kind of thing. There aren't many, Manchester's maybe another one, but there aren't many groups that really do a lot of web. So, onto the web stuff. First thing to be aware of, not all web apps are the same. So when you think, I'm building a web app, that means a lot of different things. Some are just websites. So this goes back to the original days of the web, or like certainly when I started making websites in at school, open your text editor and start manually typing HTML into a text editor kind of thing. There's no, they're typically static content. So the markup for the structure of the page is there with the content in line. There's little to no interaction. You might have bits of JavaScript that show and hide different things and button presses and that, but there's not any sort of, because there's no server-side component, there's no submitting information, retrieving information back, there's no database, anything like that. In the modern world, these are typically built via generators. So this would be things like Jekyll, if anyone's used GitHub Pages, or things like Read the Docs will use a different generator. What those generators spit out is just static HTML with content in line. They just save you the bother of handcrafting that by taking something like Markdown or CSV or whatever and running it through a generator. Some have no user interface at all. So it's tempting to think of web apps as, oh, it's a website, or at least it has a browser-based user interface, even if it's a full-stack application. That's not actually true, because most API calls on the web, this data is from Cloudflare from 3 years ago, and I'm sure it's only gotten worse since. Most web traffic is API calls, different services talking to one another RESTfully over HTTP. So when you think about that, making a back-end web application that just exposes itself through a REST interface is still a web app. It just has no user interface on it. But the technologies used, the way you approach those problems, security on the web, things like SSL, all of those things are still in play. So it's still a web app. Some are obviously full stack applications. This is your typical standard thing would be like a 3-tier approach. You've got a database, some sort of middleware component that's talking to your database, and then a browser-based client-side app that talks to that middleware. And that's fairly common. That's been around for a very, very long time. In more recent years, this has changed a little bit just because of the types of technologies and programming languages that people are moving towards. So languages like PHP and even some of the Python-based web frameworks will do server-side rendering. So there's less of a distinction between those two layers. But a personal preference of mine is to have like a really hard separation where I only make client-side JavaScript code, and I'll use JavaScript frameworks for that, that talks to an API that I can build in some other language. It doesn't matter. So I could write my backend in Python as a Flask application or something like that, and then use Vue or React on the front end. And there's no tight coupling between those two layers. But that's personal developer preference. I'm not here to evangelize one way or the other. Interestingly, some are hiding on your computer or phone. So some of the most popular desktop and mobile apps that are out there are actually web apps masquerading as desktop apps, in that they're entirely built using a system called Electron. They're all built with HTML, CSS, and JavaScript, and then wrapped up so that they're like one-click deployable depending on the context. Like, is it a desktop app or is it in the App Store? Spotify, Google Maps, Slack, Facebook. There's many, many more, but these are all basically written by web devs. They're not native apps. I'll get into this later, but there are various pros and cons of this approach. I'll get into the detail later. Fundamentally, though, all web apps are actually the same. For a few very simple reasons, which is HTML, the markup that describes how to structure a web page, document, has gone through some iteration, sure, since 1991 when it was invented, but it's fundamentally not changed. They've added a few DOM elements and that kind of stuff, but the way it works hasn't fundamentally changed. And all web apps still use that. It's based on the HTML, standard markup language. So when Tim Berners-Lee invented the HTML stuff, it was based on that. And there are a bunch of tools that will make your life easier when creating HTML, or they'll generate it dynamically. But the build out, when you're deploying something that is a web app, the thing that you're deploying is still just HTML and CSS and JavaScript. It doesn't matter whether you're using like React or Vue, or whether you're using Django or what, like it all boils down to that. It all comes back to that, because that's what browsers interpret, and you're beholden to what the browser will render. Hilariously, and I wish I was able to find more screenshots of this, in the 4 years intervening 1995 and 91 when HTML was sort of out there, and then CSS come along. So CSS stands for Cascading Style Sheets. It's a method of describing how you want your HTML to visually look. So think of it as HTML describes the structure of a document. It describes the gaps between paragraphs, what's a header, what's standard body. It's giving you a structure to some text. It's not necessarily being opinionated on that title is red. That's a CSS job. That's not a HTML job. But the original intent of HTML was that it wouldn't care about styling. That was a browser decision. So if you wanted, if you went to the BBC News site and you didn't like the look of it, the official advice was change browser, because someone else's browser implementation would just render it differently, and maybe you like that. So this obviously didn't last very long. Not very good way of approaching it. So then CSS came along. A lot of developers have a bit of a love-hate relationship with CSS because it can get convoluted because you've got this cascading way that the rules are applied, which does make logical sense. But once you've got a reasonably sized website or web app, there are so many rules that they start to interplay with one another, and it can be difficult to pin down exactly where one browser dev tools have got a lot better. You can highlight bits of your element and say and look at all the rules being applied in order. Before any of that was a thing, certainly when I was at college and university, you would end up just have this assignment screaming at the page, like, why is this title red? And you have no idea because you're having to trace through all these rules, which is where this love-hate relationship comes with it. But it does allow you to do incredible things once you're more focused on the design aspect. When you're trying to realize something, it can be very powerful. In the modern world, very vibrant ecosystem of preprocessors and frameworks. So preprocessors allow you to sort of squash that rule set and make things a lot easier to understand as a coder. And then the frameworks give you a lot more sort of design structure. This would be things like Bootstrap, if any of you come across that. It's something you can just throw at a website and it instantly looks better. The problem with those frameworks is that then, because it's that easy, all websites then look the same. They all look like Bootstrap. So yeah, pros and cons. JavaScript next year came along, originally created for Netscape 2, but it was really the growth of Internet Explorer that drove JavaScript forward as the programming language for browsers. And then it was moved under ECMA via like Mozilla. Really the thing that has driven JavaScript forward in the last 5 years or so has been the explosion of Node.js, the idea of being able to run JavaScript outside of a browser, to the point that NPM has the most modules now of any package manager. Has anyone played the NPM drinking game or know what it is? Right. So JavaScript devs have this weird obsession with naming all of their modules just random nouns.js. So it'll be like pineapple.js, and I can guarantee that's a module, by the way. They're not well, some of the good ones are self-describing, but often it's just some random word.js. And because there are so many, there's a website you can go to that's the NPM drinking game, and you just go around and put in random words, and if it's a package in NPM, you drink. That's the idea. I mean, slightly ridiculous, but it does show you the huge popularity of JavaScript. Around the time Node came out, it really pushed forward the speed of development of JavaScript. And this was a big problem because JavaScript itself was moving very fast and you could do more and more amazing stuff with it. But the release schedule of individual browsers was still pretty slow and pretty poor. And so you'd end up in this position where you were making applications.
Apparently Pineapple is a testing framework.
There you go. I didn't even know that. I could just like, as soon as I said it, I'm like, I bet that's a package. Yeah, so basically you end up with this problem where developers were making really hacky JavaScript code because they were having to bake in backwards compatibility as the developer rather than the language doing that for you. I once had a technical interview at a BA, a full stack web developer, and the technical interview part was, they gave me like an A4 sheet of we want the page to look like this. It was a CSS and JavaScript challenge, but the thing was it had to work on Internet Explorer 6. And at the time, IE11 was out and IE6 had been sunlighted by Microsoft. But because some non-insignificant percentage of their customers approaching the BA website was still IE6, they wanted IE6 compatibility. And the code was just awful because you're coding for all the new browsers and the huge chunk in the middle that's like 1 or 2 versions behind, and like the 5% who are like 5 or 6 versions behind. Then something came along called Babel, which is a transcompiler. It basically allows you to write in modern, at the time it was ES6 or ES5 JavaScript, and then it would generate JavaScript files that would handle all of the backwards compatibility for you. And that was really pushed forward because of the growth of Node. There was such a huge shot in the arm for the JavaScript sort of development community that these tools were really needed. Someone got around to actually building it. And it caused the long overdue death of best viewed in Internet Explorer. So you used to have all these web pages that had little icons and buttons, and this was because the developers were either too lazy or like just couldn't figure it out how to give the same exact experience in every browser. And that's because different browser implementations of the JavaScript framework. Thankfully, that is a thing of the past. Well, yeah.
Substituting Chrome?
Yes, yeah. Well, that's a Google marketing thing rather than it's not a. The old thing was probably true in that there was a lot of development technical challenges making it work. Yeah. So to move on slightly to what we do at Newcastle when we get individual projects that come along, and how we think, right, not all web apps are the same. What are we, of all of these tools, what are we actually going to use? What is the approach we're going to take? The first thing really is that although it's not as exciting and sexy to use the latest frameworks and all the rest of it, there's still a huge place for static websites. And so there needs to be a really, really good reason why you're not making a static website. And that reason can be pretty obvious, like I need a database, or maybe there's some portion of the application that's behind a login. You can't do that on a static website. As an example, the screenshot in the background there is the infant chemotherapy dosing guidance website. Amazing project to be part of. Pretty horrible sort of subject area, but really important. And they came to us with a load of CSV. No, it wasn't CSV files. It was tables in Word documents. Yes. So we turned all that into CSV, and through the requirements capture stage and all that conversations with the academics, sort of became obvious that they weren't going to update this all that often. So it was a lot simpler to rely on the CSV, write some markdown files, and run the whole thing in GitHub Pages, and just use Jekyll to render some static websites. They didn't. The website itself, the point of it is information for clinicians who've never seen some of these very rare neonatal cancer cases to come to and look at banks of evidence of what's worked in other cases. So it's deliberately not behind a login or a paywall or any of those kinds of things. So static websites are still used a lot in our team. API generation is a sole problem. So when we talk about APIs, the second type of web app I mentioned, we almost exclusively use a tool called Strapi. It's a node-based sort of JavaScript tool. There are others like it out there in other languages if you don't like JavaScript, Python or something like that. The point of it is you can install it and then through an admin dashboard make some data models. And as soon as you've done that, it gives you what are called CRUD operations on all of those data models, CRUD being create, update, delete. So you can go from nothing to full API with security and documentation in Swagger in about half an hour with this, rather than opening my IDE and starting to write Python or Node or whatever and trying to handcraft my own APIs. When you're doing quite basic, like repeatable things of creating and editing and moving objects around, there are so many tools out there that just do that for you. We encourage our devs to use Strapi or similar to focus on the bits of the project where that doesn't work, because all of these tools are editable. So you get your CRUD operations sorted and then spend the rest of the time writing custom endpoints for the bits that are a bit more tricky. Learn languages, not frameworks. So we've had, we see this mostly with like CVs and people that we interview and stuff, and even like the people we hire. They'll come in and they'll all have particular preferences, is probably the polite way of putting it, on which JavaScript framework that they like to use. So there's things like React, Vue, Angular, there are others. And we try and teach that out of them by saying, no, focus on the JavaScript. Like if you can show me you're a JavaScript dev, I can give you one of these projects and you can choose which framework it is, and we don't care. There are other groups in RSE teams around the country, perhaps, who do mandate the use of certain tools or setups or whatever, we try to focus on making the team as interesting a place to work as possible. And so we encourage people to experiment within a sort of walled garden. And we don't mandate the use of one of these frameworks or another. We leave it up to the individual developer to choose the right framework at the right time for the right project. But we're very clear on that at interview and induction stage and that. So if people come in saying, I'm a React developer and I only do React, well, that's great, but we might ask you to work on this Angular project because you know JavaScript. That's the thing I care about, not which framework you know. The tool in the background there's the custom team administration tool that I built using Vue. Yeah, pros and cons of cross-platform frameworks. So cross-platform frameworks for mobiles, you can write mobile apps in web technologies using one code base. That's the big set. That's the big pro to it. Write once and then get that same app in both app stores. The downside is that you can, depending on what your app does, you can sometimes get subtly different behavior across devices like Android versus iOS, or slightly different look and feel. That may not be something you care about because there are not that many people in the world who are readily walking around with with an iPhone and an Android in their pocket using the same app, complaining it doesn't look the same. Most people are blissfully unaware that their app looks different to their friends. It's a little bit of a castle built on sand sort of thing, because to interact with the low-level hardware, there's a whole series of modules that are often open source that people contribute, which is great. But you're beholden to the hardware teams and those open source communities to maintain those modules. So if you want to use the camera, you've got to make sure that all these modules are aligned and up to date and all the rest of it, versus just writing native code, which there isn't that between you and the Apple SDK, for instance, or the Android SDKs. So it's really a question of, do you have the time commitment to put into what is effectively building two apps? It's like running two projects. You can save some time around that by having a common set of design standards. Do your user interface design in Photoshop once, but there's still two implementations. It's a very tricky area. There are people in the RSE community who feel strongly one way or the other. As a head of an RSE team, I don't mind so long as the project gets delivered and the PI's happy. I leave it to my devs to worry about that part. Most of the time, I would say that we use React, and we've also used Flutter, which is a similar thing, came out of Google. I don't have any strong opinions if anyone's going to ask me about which cross-platform they need to use. I'm open to persuasion.
Yeah, so I remember that Adrian from Manchester, who is now the head and used to head the web team there, was saying they have a framework from which they then develop everything, and that's much quicker. Yeah. So have they chosen one, or it's a different type of thing?
So theirs is also cross-platform. You might have to correct me if I'm wrong on this. I think it's Xamarin, which is this might also be wrong. I think it's a .NET based. It's still web, but it's not JavaScript based. It's yeah, I think it's .NET based, but it's the same principles apply. It's a cross-platform.
I was looking into something that used to be called Genie, Jinni. So it allows you to write the business logic in C++. Oh, that's a weird choice, but you do write it once, so you don't, and that applies to both iOS and Android. And then it uses an interface description language, an IDL, and a tool to automatically build the bridge between the C++ language and the native SDK. So like your example with the camera, you're still calling the SDK's camera function, but you have a sort of lightweight wrapper that's auto-generated that you call the consistent interface from your code. But that's right, it was Dropbox, that's what D stands for, Genie. Dropbox created it and went around the C++ conferences and hyped it, and then famously 4 years later dropped it. So, yeah, that was a mistake. We're not doing that anymore. But the community have picked it up. It looks like a good idea. idea, but nobody seems to do it.
Yeah, it's everyone's grappling with, but no one has really solved this problem of how do you efficiently and easily and sort of well, not securely in a security sense, but like reliably build formats. It's hard.
Have you experimented with progressive web apps?
We have, yes. So we used React Native, and you can put that into like a progressive web app mode rather than building. It might just be regular React you do that with. I can't remember. But yeah, I think we've done one project that, so that's on the water. I don't really have a lot to say, but I didn't work on that project. Well, I never work on any projects sadly anymore. But yeah, I don't know a ton about that.
Okay.
It's an interesting area though. Okay, so once we're deciding either it's a static website or it's a mobile app or it's a full stack application, what are we going to do? As a team, we just decide the rules of the road as to where we're regularly going to deploy apps. We're not so hard about it that we say you must deploy your web app here, but we have a standard way of doing it. And then if someone wants to make an appeal to say, oh, no, my app is special. I made it, and therefore it's going over here. So, you know, they can make a case and we'll have the room and they've got to argue that point. But we never shut it down and say, no, you must do it here. In our case, most of our stuff is on Azure or AWS. There's other bits running on Google, and the less said about Oracle, the better. Because you do that, though, it forces this build-up of institutional knowledge of the way to do it that you can just pass down, so that even the people who put those building blocks in place who may now have left, everyone else is still using the fruits of that labor. Some of that process is documented, which is the right way to do it, but some of it is just because that's how we've always done it. It's like an undocumented way of just, you know, team knowledge kind of thing. You must have this yourselves with the way that you do some things. Yeah, my hot take, virtual machines are dead. Don't use them. More on that in a minute. So we really early on, even before I started the team, I think I've been using cloud computing for about 10 years or so. So we tried to look at something like a full stack web application where you've got a database, some sort of middleware layer and a front end, and think, how are we going to do this on the cloud? The obvious answer is there's so many cloud native databases to choose from of all types, of all pricing tiers, of whatever memory you need to do that. And then the reason I say VMs are dead is that we use app services or serverless functions to run all of our middleware stuff. And the reason for this is that we can build Docker containers in GitHub and move containers around. We're never ever starting VMs, logging into VMs, patching things. We have a standing order not to use university virtual machines for that very reason. They started pushing down maintenance and security responsibility to the owners of the VMs, like the individual people who requested them, which is often an academic who might be an archaeologist, or they know how to do Linux patching. Yeah. So we get around that problem by just saying we care about containers. So that means that whatever the middleware component of our full stack application is written in, it could be anything. Python, Rust, Go, doesn't matter. If it can live in a Docker container and talk HTTP, you can deploy it anywhere. So we run that and we get it to talk to whatever cloud hosted database we have or we want. And then we'll often use GitHub pages or storage containers for the front end code. So we'll have a build process that spits out this static HTML and JavaScript and CSS. That's a little bundle, and we can put that anywhere. There are, in Azure, there are storage accounts, a bit like buckets in S3, if anyone's ever used that, where you can, in the configuration for the storage container, you just say, this is a static web application, and you turn it on and it gives it a DNS address and all that kind of stuff. So you can just put your HTML there and it'll start serving it like a website. And that means we don't have to run a website because Azure are doing it. So very handy. We genericize at the repository level. What I mean by that is we have a bunch of GitHub template repos that are for specific tools that we ask people to build on top of. So for example, there is a Strapi repo there is a vanilla but freshly installed version of Strapi that's up to date with the latest version. There are Terraform scripts to build out a MySQL database that Strapi relies on, an app service, and a storage container for the client-side front end, and all the GitHub workflows to build all of that and do all of the deployment. So that means as soon as someone starts a new project with a new repo and bases it off that template, they've got all that stuff ready to go and it's done. They get on with actually doing the project rather than all of their DevOps and all the plumbing that's the boring. And we slowly parameterize these workflows so that you can, because obviously not all projects are named the same. So we have like these config files where you just stick in the name of the project and then it builds from that the names of the storage accounts, the names of the app services and databases and all that. It's just usually project-database or project-website or whatever. And then the same with our infrastructure as code. So we use Terraform for that. Do you know what I'm talking about? Infrastructure as code. And that brings uniformity across the different deployment environments. For larger projects, we don't do this with every project, but for larger ones, we'll often have a staging and production environment. And it's very important that they're essentially the same, just so you're going to get like uniform behavior. What you do in Terraform is just have that environment done once, and then you just say, I want two of them. One of them is called staging, and one's called production, and I'll just label them all like that. And then putting it all together, we basically treat GitHub as the source of all of our deployment actions. There are some things we do where we might use VS Code to sort of manually deploy things, and especially while we're doing early jobs in projects and testing things out, we might do manual deployments. This is another reason we got rid of the idea of using VMs. No one SSHs onto anything and runs any pull commands or anything like this. A general rule of thumb is we have a main and a dev branch. Main is always protected. Any push to dev, and this is all in our template repos as well, any push to dev will trigger a build. Any push to main will trigger a build and then a deploy to staging. And then a tagged release on main will trigger a deploy to production. That's our general, there are some exceptions to that, but that's our general approach to using Git for the start of our DevOps pipelines. And that way, when we do a tagged release in GitHub where we say, this is version 2.1, that tag will flow through and kick off those builds and deployments, and it will all just, that's the way we approach deploying web apps. Before I move on to the sort of design and UX stuff, is there any questions on any of that?
What do you do about pricing and stuff? So is all of that pushed onto your like clients, the researchers?
Yeah. Yes, there's two answers to this question. So for large projects that are going to involve a lot of compute, those projects foot the bill. But that's because at the grant writing stage, we'll do all of the calculations to figure out what they need and then put a decent like 20% contingency envelope on that. So they're happy with paying because they've got the budget to pay. And then internally to the team, we have a very healthy non-staff budget that we use. And most of our web apps, if you're talking about, I'll use Strapi as an example. So it's got MySQL database, it's running a single container running Node, and it's got a client-side element to it. We can run one of those for about £15 a month. So it's not a lot really. And we just pay for that out of our own budget. My rationale for that is we're set up as a research facility, so we have a day rate rather than charging people directly to grants. Our day rate is about £400 at the moment, and it would take an awful lot of cloud time versus 1 day of an RSE. It's just the economics are not worth it. It's cloud all day long for these things. You can run up huge bills on the cloud. That's on the fringes. For the day-to-day of running basic web applications, it's more than worth it.
You mentioned containers and disparaged DevOps, but you haven't sort of described how you cope with more than one container that are interacting. Mm-hmm. So do you use Docker Compose or Kubernetes or?
Yeah, we sort of leave that up to the individual projects to where that line is, and it is fuzzy. So I think a lot of people, the temptation is to hang on to Docker Compose as long as they can because it's so much simpler. But then there is always this point where you just have to say, we've got to go Kubernetes. Required reading for new web devs in our team is the Children's Illustrated Guide to Kubernetes. I don't know if you've seen that. So yeah, we find we do have a lot of Terraform code to spin up some of these things. We try and take the deployment of a Kubernetes cluster away from people, but it still requires an awful lot of understanding to how these things are actually working to really grapple with them. Thankfully, not too many. I think 3 or 4 projects I can think of are running on Kubernetes. There's probably 10 times that of these more standard like 3-tier applications. So our bread and butter is a bit simple, but yeah, we do use Kubernetes.
Are these templates open source?
I believe they are, but I can check that. Yeah, I mean, they're, I always caution that they're heavily informed by the way we think do things at Newcastle. So I wouldn't approach it as, oh, we'll just take this and run with it. You'll need to treat it more as look at them and be inspired by them to do what you want to do. Is what I would suggest.
But do you handle backups? I guess that's just another thing. And high availability, is that just for the bigger ones which use Kubernetes maybe?
Yeah, the bigger ones for Kubernetes will turn on different availability ones in the cloud, and we just let Microsoft and whoever handle that for us. But some of the services like the backups, again, that's some of that is written into our Terraform code. So to use the Azure example, they've got this thing called Key Vault, but again, there are others in the US, whatever, that backs up a lot of the environment variables and secrets and certificates or whatever's needed. I sort of glossed over that because it's a pretty detail, but it's all in there.
I might just be the only person who can't quite follow, but I built a website by faking it till I made it and stuck it on a virtual machine.
Yeah.
And so it was built in Flask. I understand that there's things to generate the HTML. I wrote some stuff to run Python code behind, and there's a SQL database. So I understand how all of that sits on one machine. When you're saying you just put the code bits in container, you put the sort of the front end on GitHub.
Yeah.
How does that know where to talk to each other and run? Surely it's running on something, or is that the beauty of AWS?
Yes.
Right. Okay.
It is, yeah. I'm being facetious about VMs. Of course, they're AWS and Azure are running the VMs. The difference is I'm not running them and I'm not responsible for patching them.
Right.
What the interface you get given instead, either through the command line and the SDK or through the portal, if you prefer the UI view of everything, is more like a configuration object where you're just saying, this is my container, and you'll give it, it will give you a DNS address, like a web address, but you can also give it a custom one if you want a custom domain name. And really what you're doing is telling your client-side code, hey, my API, my middleware is over there, it's at this URL. And that runs there in its app service. And then the app service knows the IP address, the database, and that's secure because that's on Azure's internal networks. You don't ever need to directly connect to the database. You can do it for development, but you then turn that off. That's the idea. Yeah. So I'm going to talk now about some design principles that I always tag onto things. So I always look at this book because it perfectly captures why design is important. So a user interface is like a joke. If you have to explain it, it's not very good. You want your, well, I'm going to step back from the word user interface slightly here, which is to say everything I'm about to put on the next few slides is just as valid when you're making a poster for a conference as it is about making a website. These are like foundational principles that you all know them and you would have picked them up at nursery with crayons. That's the level I'm pitching this at, right? But people forget them. The first thing is to be really helpful to future you by remembering that pencils and paper exist. There is a temptation when you're thinking, oh, I need a user interface, or like I'm designing something, I'm making a poster, I'm going to go straight into Adobe InDesign and I'm going to start making things out, or I'm going to go straight to my CSS and start like live coding my user interface until it looks how I want it to look. No, think carefully about the way your application hangs together. What happens when you press, or what do you want to happen when you press on certain buttons? Where do you go in your application? Is your menu structure getting too big? There are so many websites where there's like a menu across the top of the page and they've basically got too many menu elements and the page is like massively wide, right? Because they've not thought about the structure of their site. So these designs don't have to be good. They just have to be your doodles on paper where you can really sit down and just draw. Like people need to get back to drawing. Thinking grids. Everything is in grids, and HTML enforces this on you naturally anyway because everything is square. It's possible to make curves or like put curved media elements, images and things on the page. But the way to approach things like responsive design. So responsive design is this idea of same code structure will render differently depending on the size of the screen. So rather than having like, it used to be very popular when the mobile first came out that there was a mobile web page and you would go to this URL for the mobile page and then you go to this other URL on the desktop. Now you just go to one URL, and that's because it's the same code rendered differently depending on your device. And the way it achieves this is it's usually a 12-column grid, but there are others. And everything's done as proportions. Like this element on the page is 50% of the screen. This element is 30%. And the reason it's 12 is because that's nice and divisible by everything. So yeah, when you're thinking about structure, divide the page up, think in columns and rows and portions of this page available. Don't think in terms of, I have this image and it's 500 pixels wide and it's going there. Think percentages. Respect negative space. So a lot of us know bad design when we see it, or when we see things that are just a bit jarring or uncomfortable to look at. You'll all have this experience of one kind or another. And you'll sort of notice when it's good, and it's sometimes making it difficult to put your finger on why you feel like that. A good example is this one, which is the amount of white space between these elements, these three elements, is really tight, and it looks like constricted, right? All this person has done here is increase the spacing, and it just instantly looks better. It's a very tricky thing to sort of put your finger on sometimes. It's the same here, the labels, and the nice spacing between things. It just shows you the way you can group. There's spacing between elements themselves, which is, in this case, a text box and the label, but also the spacing between things when you've got stuff in groups is sort of important as well. Go easy on the eyes. So there's I don't even know why the defaults are still like this. So even in CSS, defaults just white background, black text, same word. Why? It makes your eyes tired if you're reading a lot. This is why people have, the dark screen at night and that kind of thing, or they'll change their color balance. Almost black on almost white is always better. So think carefully about that when you're choosing your font colors on whatever it is you're working on. Color is super powerful. It can completely change our understanding or expectation of what a thing is or will do. Just another line across the middle there, but basically that's the same sized object, just color different, and your expectations are immediately different. So color is probably the most powerful element in a designer's toolbox. The choices there, that both in terms of individual elements and how you might color them, and also the palette, the overall like combinations of colors is really important. So think carefully and use it sparingly. We're also all products of our culture, we came from, where we grew up, where we've been influenced by, if we've lived anywhere, that kind of thing. Colors have significance. It can mean luck, danger, or warning, or healthy. You may think of things like healthy food or recycling. You think, oh, it's green because the logos are all green. Or warnings of danger would be red in the Western world, at least. So you also need to be aware of the context you're operating in, who your users are, whether they might infer certain things on your color choices or not. All of this is important. Pay attention to the context that your users are in. So what are they doing at the time they are using your application? Mobile is a really good example of this because you can assume that they're on their phone, but that opens up Pandora's box of other problems, because are they sat down potentially with two hands available? Are they stood on a crowded bus? trying to reach the close icon on your notification because you put it at the top of the screen, way away from where they can physically reach. You'll have noticed this probably several years ago now. There was this when mobile apps first started coming out, and like launched the iPhone and all the rest of it. People made apps that looked like websites, so the menus were always at the top. But then everyone realized, well, hang on a minute. Users, especially with the ginormous phones we have now, no one can actually reach our menus. Big problem. So now most mobile apps, the menus are at the bottom, so you can easily reach it. And that's just being aware of basic biology, limitations of the human hand and the context of what someone's trying to do. You can also make assumptions and make good assumptions. So this is a really good example from Monzo, where you're opening the app for the first time and sort of making an account, and you need to verify your identity. The sort of lazy approach to this would have just been to have it in the middle of the screen and the rest of the Monzo app available as it is on the sort of home screen dashboard kind of thing, with links to the terms of service and the about us and the contact and all the rest of it. But Monzo, the developers realized that these 3 steps are like really super important. The person has to get it right, because if they send a fuzzy photo or the video is rubbish or whatever, they have to do it again and again and again. So they strip everything out. The assumption here is the user is trying to verify their identity. Nothing else matters. Get rid of all the other elements on the page and just focus on getting them through that task. And that's fine. There's a temptation sometimes to think about your user interface as, I always need to have the menu available. I always need to have these features available. Think very carefully about whether that's actually true. Always test your assumptions, but you are allowed to make some good ones as well. So my design takeaway there, I use some principles to frame your work carefully about color and spacing and text and all those things. Understand the power of the medium you're designing on. Is it a poster? Is it a web application? Is it a leaflet? Could be anything. Use tools to help you plan your design. So use pen and paper, but you could use like wireframing tools. Adobe suite of products is there if you need it. Don't be afraid to copy from others. Be inspired. Look around the web. It's good to look at other people's designs of whatever type, and you'll have that visceral reaction of, that's really cool, or I really like the look of that, or actually I really hate that, it's ugly. But go deeper and try and notice why you think that, and then the answer to that why you can take with you as inspiration for the things that you build. And then all design is exercise in restraint. It's about not just throwing everything on the page. Think carefully about the elements I'm putting here around the page. Do I really need them? And that'll get you through. So yeah, just to quickly wrap up, web applications literally everywhere. On Node runs on IoT and has run on HPC. I wouldn't recommend it though. Use the right tools for the right job, not just what you know. Don't just think, well, I know Django or I know React or whatever. I'm just going to always do that. Be flexible when it comes to web apps. And the UI UX is vital. I think consideration of design in a range of spheres is an undervalued area of RSE, but that's my high horse. Yeah, I'll take any more.
Thank you very much. And so if anyone's got any questions here, they can stick their hand up, or if anyone's online, stick it in the chat, or stick a hand up and you can ask.
I've got one. So if I was going to be interested and disagree with the flexibility thing and say, I want to write a web app, but I want to write the business logic in Fortran. That's what I know. That's what I love. It used to be that was impossible, but now WebAssembly exists. What are your thoughts on WebAssembly?
So an interesting thing, just as a slight aside, is I think it was a couple of years ago, someone wrote a web renderer in Fortran. So that must be a related project. My thoughts are that I don't really have any problems with it, because I always think that it's good to meet developers where they are. I mean, there's a whole range of reasons why you might make poor technical choices. Might be speed or just efficiency of a language in a particular context or something like that. But given the speed of hardware. People are quibbling over second response times. That is it really worth it in terms of a developer learning a whole new language to save a few microseconds? If you want to write Fortran and put it in a Docker container, then have at it.
Show us.
Thanks for the talk, Mark. That was really, really excellent. And as somebody who's worked on a lot of RSE web app projects, it was great to see kind of really high level overview. So you kind of describe your kind of out of the box approach to the sorts of projects that you undertake, and of course there are like quite a lot of different things that PIs may ask for in web apps, where maybe things like Shiny or Plotly Dash and these kind of minimal frameworks might suit them quite well. The kind of the approach that you're describing, does that kind of lend itself to a whole range of different tasks, or are these kind of for a particular set of jobs?
It's a good question. There are a range of tasks that we would support. So on similar lines to the Plotly stuff that you mentioned there, we've had situations where in terms of web apps, we might go as far as the API and then connect something like Power BI or Tableau to that to let people do their own visualizations, or even just provide the API endpoints to them and say, connect our studio up to this and pull the data from here kind of thing. So sometimes there can be a meeting in the middle. We try to be as flexible as we can. I'm hoping that's coming through in the ethos of the way we approach web applications. We have some rules of the road, but we don't hold on to them such that it stops us from doing work with PIs. Like if they've got some very particular requirements, we of course factor that in terms of the approach we take and the technologies we choose.
Do you have any perspectives on serverless? For example, you said you can't put a static site login, but something like AWS Cognito can be used to provide authentication.
Yeah. So I'm a big fan of serverless. I think it's a really good way of compartmentalizing different aspects of your application. And I take the point about running static sites. It is possible to put static sites behind authentication. I was using that as a bit of an example of scenario where you would traditionally need to use a database of some kind. But yeah, I'm a huge fan of serverless. I use it quite a lot. As an example, I've got some code running that syncs 3 different applications together, pulls information from third-party services that we use, combines them all together and sticks them somewhere else, and that just runs every 6 hours. So yeah, I'm a fan of that approach. Another way of not having a VM.
In that case, I think that's all the questions. So I'll just say, if we can thank Mark once more.